Hello.
हाँ सर सुनाइए।
हाँ सर सुना है।
Yes, sir.
Okay. So today what we will do is that we formally start quantum field theory course. Unlike other years actually I used to spend some time for motivation, but due to these technical glitches, I cannot start at the very beginning. But of course, as I go on, I'll be talking about wherever it is necessary. Okay. Now you see that in particle physics, আচ্ছা মৌসুমী পারভিন তো ছেড়ে দিয়েছো নাকি? হ্যালো হ্যালো Okay. Now, in particle physics, what we do, we use a kind of unit. It's called natural units. I think that you have heard of natural units earlier. Yes or no? আগে কেউ শুনেছো ন্যাচারাল ইউনিট কথাটা? হ্যালো হ্যালো উর্গেন উর্গেন,
Yes sir.
have you
Yes
heard
sir.
the term natural unit earlier? Yeah, so
Yes sir.
I'm asking all of you to sometime respond in terms of yes or no. Otherwise, it's very difficult for me whether I am talking to the blank screen or some students. Okay, so that's what I'm asking
Yes sir.
repeatedly some of you. So without any hesitation, maybe all of you together can respond that yes or no. Okay, so why do we need natural units? You see that you know that when you study the standard physics, maybe starting from class 8 or during your school days, or maybe even earlier, I don't remember now. So we learn about units. There are SI units, CGS units, and many things. But in particle physics, we use natural unit. There are certain reasons for this. So, for example, there are some fundamental constants in nature. Number one, velocity of light. Number two, Planck's constant. And then number three, gravitational constant. Now we'll see that velocity of light, it determines if the object of if the velocity of an object is close to the velocity of light, then we call it's a relativistic particle. If it is very very small, then it's called non-relativistic particle. So this fundamental constant can be used to define whether a system is relativistic or non-relativistic. Similarly, H bar is used to define whether the system is quantum or classical. For example, if when you talk about classical quantum correspondence, we take H bar goes to 0. Okay, so that's the limit from going from quantum to classical. Similarly, Planck's constant is in terms of gravitational constant, whether the quantum gravity is at work or not, it's some kind of measure of that. Now, since we'll be learning quantum field theory, or for particle physics, quantum field theory is the right description or the right tool for studying particle physics. So it's a marriage of relativity and quantum mechanics that produces the offshoot quantum field theory. So whatever formula we calculate for experimental verification, theoretical predictions, it will involve this fundamental constant velocity of light, Planck constant h bar, and also if you are working including gravity, then we will get the gravitational constant, or if we define some Planck constant in terms of the gravitational constant, then that Planck constant. Okay, and it's not a good idea to work with this C, h bar, and g hanging around in your formula, because if you remember that the velocity of light is a very large number of the order of 10 to the power 10, Planck constant is a very small number, so is gravitational constant g. can you tell, any one of you tell what's the order of Planck constant in some unit?
10 to the power
এবার আমি তোমার কথা শুনতে পাচ্ছি না। 10 to the power, hello,
-34.
gravitational constant, sorry, h bar কি ঠিক বললে? এনিওয়ে
স্যার
হ্যাঁ বলো বলো শুনছি।
1.05 into 10 to the power -34.
কি একটা ইউনিট আছে তো, একটা ইউনিট না বললে ওটা কি মানে দাঁড়ায়?
স্যার জুল সেকেন্ড।
So anyway, instead of going to the exact number, this is a very small quantity. Similarly, if you talk about the charge of an electron and you express in some unit, it's a very small quantity. If you talk about mass of an electron, proton, neutron, or those who of you who will be delving in the realm of particle physics or astroparticle physics, there many more particles will be appearing, say pion, meson, then quark and all these things. Basically their mass and everything are very small number. Okay, so you know from your very early school days that in order to describe the length of a, say, pencil or pen, you don't express in terms of kilometers. Okay, similarly the distance from your home to your university at Shantiniketan, you don't express in terms of millimeter, right? So there are appropriate units. In the same sense, for describing particle physics or physics in the realm of relativity as well as quantum mechanics, we need a separate unit so that we don't have to deal all the time with such a small number. But what we will do, you might say that, okay, but if you want to predict something, you have to verify experimentally what you do, because those will be in terms of, say, kilogram, meter, second, arc, joule, and all these things. Okay, we just convert it. Okay, we convert it to the original unit and then predict the actual value. Now, in order to discuss the natural units, note that there are three dimensions. Length, we denote it as L, mass, we denote it as M, and time, we denote it as T. Now, in natural unit, what we do is that we take the velocity of light to be equal to 1, and Planck's constant divided by 2 pi is equal to 1. So that means I talked about three fundamental constants: c, velocity of light; h bar, Planck's constant; and g, gravitational constant. Now if we are fixing velocity of light is equal to 1, Planck constant equal to 1, then basically we are left with one fundamental constant which is not fixed. Now we want to see what is the consequence of this choice: velocity of light is equal to 1 and h bar is equal to 1. So velocity of light is equal to 1 implies that L, what is the dimension of velocity of light? What is the dimension of velocity of light? Hello?
L t to the power
Yes, sir,
minus 1.
LT inverse.
L by T.
LT inverse. So আচ্ছা একটা কথা জিজ্ঞাসা করি, আমি এটাকে যখন প্রেজেন্টেশন মোডে দিচ্ছি, মানে প্রেজেন্টেশন মোডে দিলে হয় কি দেখতে তোমাদের সুবিধা হয়, আমার প্রেজেন্ট করতে, তোমরা কি আমার কথা শুনতে পাচ্ছ?
হ্যাঁ স্যার,
হ্যাঁ স্যার।
শোনা
মানে এটা যখন ফুল স্ক্রিন হয়ে যাচ্ছে তখন কি কথা শুনতে পাচ্ছ?
হ্যাঁ স্যার, শোনা যাচ্ছে, কোনো
আমি
অসুবিধা নেই।
বেশ, আমি প্রেজেন্টেশন মোডে দিচ্ছি, দিয়ে কথা বলছি। যদি অসুবিধা হয় আমাকে কেউ একটা জাস্ট হোয়াটসঅ্যাপ করবে, কারণ প্রেজেন্টেশন মোডে দিলে হচ্ছে কি আমার পুরো ল্যাপটপের স্ক্রিনটা প্রেজেন্টেশন মোডে হয়ে যাচ্ছে। তো তোমরা আমাকে কেউ একটা বলবে যে না দেখতে পাচ্ছি না, তাহলে আমি এরকম ভাবে ফিরে আসবো। ওকে?
হ্যাঁ স্যার।
Okay, so the velocity of light is equal to 1 implies that LT inverse is equal to 1. So that means in natural unit, dimension of length and dimension of time are treated as equal. Now, h bar is nothing but angular momentum. Now, why angular momentum? Why angular momentum? Can any one of you tell why angular momentum? Dimension of h bar?
both
দেবাশিসের কথা শুনতে পাচ্ছি না।
অ্যাঙ্গুলার মোমেন্টাম সমান n h বার হয় কোয়ান্টাম মেকানিক্স।
বোর কোয়ান্টাইজেশন কন্ডিশন। আর অন্য কোনো আর্গুমেন্ট দিতে পারবে যে কেন h bar is equal to h bar হচ্ছে অ্যাঙ্গুলার মোমেন্টাম এর ডাইমেনশন? তুমি যেটা বলছো সেটা ঠিক, কিন্তু ফর দ্যাট ইউ হ্যাভ টু নো quantization of angular momentum, right? But without knowing quantization of angular momentum, can you give one argument for which I can say that the dimension of h bar should be the same to angular momentum?
স্যার
হ্যাঁ বলো।
ডেল্টা এক্স ইনটু ডেল্টা পি ওটাও তো h বারের সাথে ইকুইভ্যালেন্ট হয়। আবার অ্যাঙ্গুলার মোমেন্টাম সমান r ক্রস p হয়।
Okay, I accept your
মানে ওইখান
argument.
থেকে বলা যেতে পারে।
I accept your argument. The dimensional, if I want to match, then h bar should have the dimension of angular momentum. Okay, I accept your argument. There are other explanations also, but I accept your argument. Okay, now as you can see that so dimension of angular momentum is m l square t minus. We already know that L and T has the same dimension, so you are left with ml, and that has to be equal to 1. So that means L and m inverse dimensions are identical. So if we write, basically summarize our results, what's the consequence of natural units by choosing that c is equal to 1, h bar is equal to 1 is that L, T and m inverse, they are identical. Now, so let me give some examples. So in natural unit, energy, dimension of energy is m, because energy dimension is m l square t minus 2, and since L and T they are identical, then you are left with m. Similarly, momentum dimension is mlt inverse. Since L and T they are identical, so basically momentum dimension is m. Now you must know that in natural unit, mass of a particle is equal to its rest mass, because this is the formula mc square, and you have taken velocity of light to be equal to 1. So basically mass is equal to the rest mass if small m is taken to be the rest mass. Similarly, note that inverse Compton length, this is m velocity of light divided by h bar, but this is taken to be equal to 1 in natural unit, and the velocity of line is velocity of light is taken to be 1 in natural unit, so you are left with m. Now now there are some important consequences of this. Say everything you express either in terms of mass or inverse mass, right? And if we express any quantity or dimension of a particular physical quantity in terms of mass, we have a term for that, we call it mass dimension. Okay, now you must have noted that energy can be expressed in terms of mass, or the vice versa, mass can be expressed in terms of energy. So while studying BSc or maybe nuclear physics course during MSc, you have noted that the mass of electron is expressed in terms of electron volt, mass of proton is expressed in terms of electron volt, and then if you are adventurous and you are studying about what's happening in CERN, what's happening in Fermilab, what's happening in other big laboratories, then you see that they are talking about the operating range of different accelerators as TeV, tera electron volt, GeV, giga electron volt, and all these things. And even they are talking about mass of a particle in terms of either electron volt or mega electron volt or giga electron volt. But you also know that these are units for the energy. This is precisely they are expressing all these parameters in terms of this natural unit, because the natural unit mass can be expressed in terms of energy. So as similarly, while studying spectroscopy, you must have noted that some of the wavelengths are expressed in terms of electron volts, inverse electron volts. Okay, because as you have seen that dimension of length and dimension of mass inverse, they are identified in natural unit. So spectroscopic wavelength is the length, but you can express in natural unit in terms of inverse mass. And again, mass and energy, they have the same dimension, so you can express in terms of electron volt. Okay, so these are the reasons. Now one might ask that, okay, fine sir, then what's the dimension of electric charge in natural unit? Because SI, 3GS and all these units, you know that electric charge has some dimension. If you ask that, then I have a simple calculation here, small calculation here. You can see that Coulomb force in three space dimension is given as F is equal to Q1 Q2 by 4 pi epsilon naught R square. Okay, I have not given the vector symbol. There is a unit vector on the right hand side, and similarly you have to give a vector notation for F. That's a while typing, that's a mistake, but that will not change our discussion. Now in natural unit, we take epsilon naught, permittivity of space is equal to 1. If we take permittivity of space equal to 1, then that, if we fix that, that's our choice. Okay, then it naturally leads to permeability of the medium is equal to 1, because the velocity of light is related to the permittivity and permeability through this relation. And as you can see that the velocity of light is equal to 1, you have chosen in natural unit. We are also choosing epsilon naught is equal to 1, then permeability mu naught must be equal to 1. Now with this choice of epsilon is equal to 1, you check the dimension on the left hand side and the dimension on the right hand side. You know the dimension should be identical on both sides. So dimension on the left hand side is M L T minus 2. So L T minus 2 you can simplify further as M T inverse, right, or what?
Yes, sir.
And the right hand side you have 1 by L square. 1 by L square means M inverse 2. On the left hand side also, 1 by L square means M square, right? Right hand side you have M square. And on the left hand side you have M square. Right?
Yes, sir.
Yes, sir.
So that means you have two charges. So basically dimension square charge. But it immediately follows that electric charge is key. Dimension আছে কিছু?
Dimensionless.
Electric charge is dimensionless. Now you must have noted that I am repeatedly mentioning about that in three space dimensions. Here also I'm talking about three space dimensions. Why I'm talking about three space dimensions? Because electric charge, dimension of the electric charge, does it vary with dimensions? Say for example, if you consider 2 dimension or 4 dimensions, or string theory they talk about 10 dimensions. Previously they used to talk about 26 dimensions. So whether the electric charge is going to be identical all dimensions or different, it is different. That's why I am mentioning repeatedly that in three space dimensions, charge, electric charge mass dimension in natural unit is 0. Okay, I'll be coming
স্যার
to that.
স্যার কথাটা কেটে গেল স্যার, আরেকবার বলুন।
ইলেকট্রিক চার্জের ডাইমেনশন তোমার স্পেস ডাইমেনশনের উপরে ডিপেন্ড করে, মানে কোন স্পেসে তুমি তোমার থিওরি ডিফাইন করছো তার উপরে এটা ডিপেন্ড করে। ওকে, the example we are talking here is about three space dimensions, and three space dimensions we have seen, you also agreed, at least one of you agreed, that the dimension of charge is 0. That means electric charge is dimensionless in three space dimensions. My question was that why we are talking of emphasizing on three space dimensions? Does it mean that in other dimensions the dimension of electric charge will be different? The answer is yes. Before talking about that, just note one more thing here, that we have this fine structure constant alpha defined through this relation, E square charge of the electron divided by 4 pi epsilon naught h bar into velocity of light. Epsilon naught is permittivity and h bar is Planck constant divided by 2 pi. In natural unit, we have taken h bar is equal to 1, h bar is equal to 1, epsilon is equal to 1. Now we put the value of E, you will see automatically that the velocity of light is equal to 1, and then you see automatically the dimension of E is dimensionless. Okay, so this is an indirect way of seeing that in natural unit electric charge in three space dimension is dimensionless. Now, whatever I was pointing earlier is that what is the mass dimension of electric charge in d space dimensions? D could be say 2 space dimension, or D could be 4 space dimensions. Okay, can any one of you say any idea? If you have any idea why it can vary, you have any idea why electric dimension of electric charge can vary with the space dimension? Any idea? It may be wrong also, but you should speak. Any idea? Yeah, sir, probably this is the reason.
স্যার স্যার ফোর্সের যে ডাইমেনশন সেটা ml স্কয়ার টু দি পাওয়ার -2 থাকবে, কিন্তু যখন ডি ডাইমেনশনে যাব তখন ওই যে আমরা লেন্থ ধরছি, মানে ডিসটেন্সটা ধরছি দুটো চার্জের মধ্যে, সেটার মধ্যে কিন্তু সব রকম মানে ডাইমেনশন ডিপেন্ডেন্সি চলে আসবে। তো তার জন্য যে ক্যান্সেল আউট হয়ে যাচ্ছিল বোথ সাইডের মাস, সেই ক্যান্সেল আউটটা হবে না, তার জন্য মানে ডাইমেনশনলেস হবে না।
একটু স্পেসিফিক, একটু ডাইমেনশন ডিফারেন্ট হবে, একটু স্পেসিফিক বলতে পারবে যে সে 4 স্পেস ডাইমেনশনে কুলম্ব ফোর্সের ফর্মটা কি রকম হয়?
কি স্যার কি বললেন?
4 স্পেস ডাইমেনশন, আমরা 3 ডাইমেনশনে বসবাস করি, ঠিক আছে? 4 স্পেস ডাইমেনশনে তোমার কুলম্ব ফোর্স বা ফর দ্যাট ম্যাটার গ্র্যাভিটেশনাল ফোর্স, তার এক্সপ্রেশনটা কি হয়? একই রকমের যে q1 q2 বাই r স্কয়ার, নাকি পাল্টে যায়?
স্যার ভুলে গেছি স্যার, মনে পড়ছে।
ধর ইলেকট্রিক পোটেনশিয়াল, এখানে কিন্তু একটু সবাই নজর করবে, এখানে আমার একটা টাইপোগ্রাফিক্যাল এরর আছে। হ্যাঁ, এখানে একটা ভেক্টর নোটেশনটা নেই, ভেক্টর নোটেশনটা দিলে আবার এইখানে আবার একটা বেড়ে যাবে, একটা ঘর বেড়ে যাবে। সো আমি ডিস্ট্রিবিউট করার আগে এটাকে কারেকশনটা করে দেবো, আমি আগে খেয়াল করিনি। না, তোমাদের কি মনে হয় যে কুলম্ব ফোর্স যেটা রয়েছে সেটা সমস্ত ডাইমেনশনই একই ফর্ম না আলাদা? বা গ্র্যাভিটেশনাল ফোর্স, বিশেষ করে তোমরা যেহেতু অ্যাস্ট্রোফিজিক্সের একটা মেজরিটি, মানে আমার এই কোর্সে মাত্র 3 জন পার্টিকেল, মেজরিটি হচ্ছে অ্যাস্ট্রোফিজিক্স, তো এটা কিন্তু খুব ইম্পর্টেন্ট প্রশ্ন যে গ্র্যাভিটেশনাল ইন্টারাকশন কি সমস্ত ডাইমেনশনে সমান, কারণ এর একটা বড় ইফেক্ট আছে, খুব আমাদের এক্সিস্টেন্সের সঙ্গে রিলেশন আছে। So for example, I'm sorry Shalini, I switched over purely Bengali and Urgen. Now actually the gravitational force or the Coulomb force, they are different in different dimensions. Okay, now when I said it has interesting consequences, say suppose who told me that we are living in 3 space dimensions? When we teach or your teacher taught you that we live in 3 space dimension, he or she tried to convince you, but looking at the classroom, that oh, this is x-axis, this is y-axis, that is z-axis, but that is not convincing enough. Okay, because string theory is talking about 4 dimensions, 10 dimensions. Previously they're talking about 26 dimensions. There are many theories about mirror universes, there are many theories about extra dimensions. So how do we really know that we are living in 3 dimensions? Okay, you may have very complicated mathematics oriented or quantum gravity oriented argument, but suppose you are completing MSc, from your family or extended family, some kid studying in say school section ask you that how do I know that we are not living in 3 space we are living in 3 space dimensions? You see that in order to answer him or her, you have to talk about very simple thing. She or he will not understand complicated things. So the one argument is that we can buckle our belt, tie, similarly we can give knot to the tie or shoestring. Similarly, I don't know, I can see 2 of your pictures, but basically in Indian girls or women, they have this kind of binuni jetake bole. So everything is related. চুলের বিনুনি বাঁধা, বেল্ট পরা, টাই বাঁধা, জুতোর ফিতে পরা. If we are living in 2 space dimensions, it was not possible to do that. In order to buckle your belt or having this braiding of hairs, okay, or tie or putting shoestring in your shoes properly, you need a 3rd dimension. Okay, so 2 dimension is ruled out. Similarly, you can rule out 1 dimension also. Why not 4 dimensions? 4 dimensions, basically we know that 4 dimension, this formula for the potential or the force, that varies differently. That is not 1 by r square, but that is 1 by r cube. Now people have studied using classical mechanics that if the gravitational interaction was varying like 1 by r cube instead of 1 by r square, or higher power of 1 by r square, then these orbits will not be stable. If you remember classical mechanics, if it is a central force, then motion is restricted to a plane, but in order to have some other property, closed orbit and all this, you need further conditions. Okay, for 1 by r cube potential, there may be orbit, but it will not be stable. If you get slight perturbation, it will move away from the stable orbit. But at least we know, or you can convince a kid that Earth is moving around the sun for so many years, billions of years. Okay, so if it would have been higher dimension, then it could have destabilized any one of the planets, and we would not have lived here to see a solar system here, or my astrophysicist friend will be looking even beyond our solar system, Milky Ways and all these billion of light years far away. Okay, so the stable orbits things should not have been there, and this is true for all higher dimensions, because this form of the Coulomb force or the gravitational force changes. So this is very interesting. I don't know whether you encountered this kind of thought earlier or not. Then you might ask, okay, I agree with you. I don't know. Do you agree with me or no? First, let me see that whether you agree with my argument or not. এগ্রি করছো না করছো না? আমি যে দুটো আর্গুমেন্ট দিলাম। হ্যালো,
স্যার 4 ডাইমেনশনটা কেন হলো না আরেকবার বলুন তো?
হ্যাঁ
4 ডাইমেনশনটা কেন হলো না ওটা আরেকবার বলুন তো?
মৌসুমী, তুমি কি ছেড়ে দিয়েছো বোধহয় নাকি ফিল্ড থিওরি?
আমাকে এখনো জানায়নি কি আমি মানে ইলেকট্রনিক্সে ঢুকেছি কিনা, তাই জন্য।
আমাদের অফিসিয়াল নোটিফিকেশন হয়ে গেছে।
ও, আমাকে তো মানে আমি জাস্ট মেলটা পাঠিয়েছিলাম, তো এখনো জানায়নি।
অফিসিয়াল নোটিফিকেশন করে দিয়েছে।
ও,
ফোর ডাইমেনশন এনিওয়ে, সো 4 ডাইমেনশনে যেটা হয় যে 4 ডাইমেনশনে গ্র্যাভিটেশন ফোর্সের ফর্মটা হচ্ছে গিয়ে proportional to 1 by r cube. Okay, so if you now study the orbit formation and their stability using 1 by r cube potential, then the result is that the orbits are not stable. If you give a small perturbation, then it will go out of the orbit. And as you know that there are small perturbations because some comet, some asteroid, it's always present in the universe, right? So that means that had it been that we are living in 4 dimensions, then the force should have been should have varied 1 by r cube, and we have unstable orbit, and unstable orbit means there is no solar system, and whatever you are talking beyond solar system, and there is no existence of humankind. Okay, so that's my argument. বলো আর কি বলছো, বলো বলো পারভিন।
স্যার ফোর্সটা কিভাবে
হ্যালো মৌসুমী,
ফোর্সটা কিভাবে 1/r³ এর প্রপোর্শনাল হচ্ছে?
হ্যাঁ
ফোর্সটা কিভাবে 1/r³ এর প্রপোর্শনাল হচ্ছে
আচ্ছা
4 ডাইমেনশন ধরলে?
গুড কোয়েশ্চেন। যদি আমরা if you would have lived in 4 dimension, then perhaps we could have measured it the way this 1 by r square formula has been derived, 1 by r square. Okay, so how it is becoming 1 by r cube? Before going to that, let me mention one more very important thing, that this q1 q2 by r square, that has been verified for large distance but not for small distance. Even today, for 1 millimeter, for distance less than 1 millimeter, this has not been verified yet. Okay, and okay, I'll be coming to that again. This Gauss law, have you not have you must have studied Gauss law, right? Hello,
Yes sir.
হ্যাঁ স্যার।
divergence theorem, Stokes theorem, Gauss theorem, and all this you have studied. Okay,
ইয়েস স্যার।
so from the space-time property, it emerges that basically that Gauss law, I mean, that can be derived purely mathematically from the space-time properties of a system, and from there this 1 by r cube comes comes from there. So for example, divergence of a dv is equal to a dot ds, right? Surface integration.
Yes sir.
Do you remember? Now if you consider small patch surface in higher dimension and assume to be a spherical symmetry, without assuming spherical symmetry also you can solve it, but it's easier for spherical symmetry, then you see that for a circle it varies like r dr, right? For a sphere, it's a 3-dimensional object, it varies like r square dr sine theta d theta d phi, right?
Yes sir.
For hypersphere in 4 space dimension, it varies like r cube dr and then 3 angles. Hello,
স্যার ওই এক্সট্রা ডাইমেনশনটা কোথা থেকে আসছে? টাইমের তো আমার তো আলাদা ডাইমেনশন আছে।
time and dimension আলাদা, I am talking about space dimension. Okay,
হ্যাঁ সেটাই বলছি, মানে
না।
এক্সট্রা আরেকটা স্পেসকে আরেকটা এক্সট্রা কোঅর্ডিনেট হিসেবে ধরলে।
আমি প্রথমে বলছি, suppose we consider the mathematical problem, that what should be the Coulomb force in 4 dimension. Okay, I am not talking about the physical existence of a 4 space dimension. I am talking about the mathematics, that mathematically how do I derive that if there is a physical 4 dimension, then the Coulomb force should vary like 1 by r cube. That's my argument. I am not talking about that there is a four space dimensions, and we are living on it. I'm not talking about that. I'm talking about how to derive this formula in a hypothetical four space dimension. Clear?
Okay, sir.
এবং ফোর স্পেস ডাইমেনশনে তুমি যদি এই যে ডাইভারজেন্স থিওরেমটাকে ব্যবহার করো, তাহলে তুমি দেখতে পাবে ডাইভারজেন্স অফ সাম ভেক্টর ইন দ্যাট ডাইমেনশন a is equal to a dot ds, integration over surface integration, and that ds, if you further assume to be spherical symmetric, then sphere in three space dimension, you parametrize a sphere in terms of x is equal to r cos theta blah blah blah, and this small surface element you get as r squared sin theta d theta d phi. But in four space dimension, that becomes a hypersphere, and hypersphere four dimension you get r cube dr, and then there will be triangle. Similarly, if you take fifth dimension, then again power of r will increase and you will get many more angles. Okay, and from there we derive this formula. Even if you follow the divergence theorem properly, then you say this. They mention that why it varies 1 by r squared three space dimension using this. Okay, so that's the reason. And the potential varies 1 by r in three space dimension, and in two space dimension the potential varies like log of r. Okay, now coming to your next question, that why, how do we get this extra dimension if it exists? Because string theory talks about extra dimensions. Okay, their argument is, initially I am just following the history of their arguments. Their initial argument was like this: suppose an ant is living on a wire that is basically a very thin cylinder. Then a cylinder has two dimensions along the length and along the surface, right? The cylinder surface you can parameterize in terms of two coordinates, but it's so small for thin wire that it's negligible. We consider it as to be a line. So earlier decades, the argument was there that all the extra dimensions were curled up small dimensions. So what is the benefit? Because if it is a small dimension, as I argued, just not argued, I gave you the result a few minutes back, that the Newton's gravitational law has not been verified for length less than 1 millimeter. So they took that if the curled up small dimensions are less than 1 millimeter, then we should not see any effect on this gravitational force, because we are not able to measure whether it's 1 by r square or 1 by r cube or 1 by r to the power 4, because we cannot measure it beyond 1 millimeter. Beyond means down 1 millimeter. So that was their argument. It could be different. And then you may say that then what about the planetary orbits? Planetary orbits are on very larger scale. If you're talking about length scale smaller than millimeter, okay, that is very less compared to the astronomical scale, and in any way it's not going to affect the planetary orbit motion. But of course, now their argument is different. Now in fact they can talk about extra large dimensions. Earlier it was called up dimension. Now one can talk about extra large dimensions. So in order to give you the idea, it's some bit complicated, but when you study BSc, that given a charge distribution, how to calculate the electric field due to a charge distribution, you have done this kind of calculation. Or there is a mass distribution, what should be the gravitational potential corresponding to that mass distribution? You have done that calculation also. So extra large dimension, they talk about that the dimension is not curled up, very small, but the mass is distributed in that extra space dimension in such a way that we cannot probe from the place where you are living. Okay, so that's why again it should not affect the gravitational law. It should not affect the Coulomb law. Okay. ইমতিয়াজ কি এখনই এলো নাকি? So we can so those are the arguments. Now if you so this is the form with the correction of the vector notation. Vector notation. Now again, you check the dimension on the left hand side and the right hand side. You will see that the dimension of the electric charge varies with space dimension, and it's not dimensionless in each and every dimension. Since I talked many things, I spent so much of time on space dimensionality and its effect in theoretical physics. I should also mention nowadays very popular subject in quantum matter system is graphene, nanowire, quantum dot, and all these things. So quantum dot is basically we restrict the movement of the electron or some other particle, similar particle, to only to a single point, and vibration, very small vibration within that point. Quantum wire is basically configuration where only one-dimensional system is considered. Both graphene and spintronics based devices, those are basically planar phenomena, not three-dimensional. Then you might think that they were talking about this not 1 by r square type of Coulomb force, 1 by r type of potential there. No, they are talking about 1 by r potential there, not log of r potential. There the basic idea is that we freeze the extra dimensions. That means if you're talking about a planar system, so we arrange the system in such a way that movement of the particles along the third direction is frozen. But you also know that quantum mechanically there is nothing like frozen, because due to uncertainty principle there will be always some fluctuation along the frozen direction, which I think to be consider it to be frozen. Now the idea of the experimentalist idea will be that how minimum fluctuation I can allow, and basically there are theoretical predictions and bounds that okay, this may be considered as effective two-dimensional system. What is important is to note the effective two-dimensional system, okay, because this novel phenomena of spintronics, graphene, and all these are planar phenomena. If you extend it to 3 dimensions, they get changes. But in those cases, we do use the standard Coulomb force. Okay, we do use the standard Coulomb force, but the novel things appear through other mechanisms, density of states and all these things. Nothing to do with that the Coulomb force. If you are really living in a planar system, then the Coulomb potential is not 1 by r but log of r. But all those spintronics based devices or graphene like things, there we do consider the standard form of the Coulomb potential of 3 dimensions. Only the difference is that we have frozen 1 degree of freedom following Heisenberg uncertainty principle, so that the fluctuation along the frozen direction is very minimal. Okay, and for each theory there are criteria when you should consider it as a 3-dimensional system and when you should consider it as a 2-dimensional system. Okay. Yes. Now I will move to conventions, but before that, whatever I have talked so far, if you have any question, I might take that questions, because otherwise you might find it difficult. Any type of questions on whatever I have talked so far. বলো কারো যদি কোনো প্রশ্ন থাকে।
হ্যালো,
হ্যাঁ বলো।
হ্যাঁ স্যার, বলছি যে
বলুন।
মানে হ্যাঁ, আপনি বলতেন যে মানে যখন 1 মিলিমিটারের থেকে কম ডিস্টেন্স হয়ে যাবে, তখন তাহলে আমি যে আর এর ওপর যে মানে কুলম্ব ফোর্সটা কি ডিপেন্ডেন্স আছে, মানে আর এর সাথে কিভাবে ভ্যারি করছে সেটা আমরা পাবো না।
আমরা জানি না, পাবো না বলিনি।
আচ্ছা, জানি না।
মানে ওই রেঞ্জে এক্সপেরিমেন্ট করাটা মানে খুবই ডিফিকাল্ট। তার ফলে আমরা এখন ওটা অনেকে চেষ্টা করেছে, হ্যাঁ, চেষ্টা করে দেখেছি যে রেজাল্ট যেটা পাই সেই রেজাল্টটা যে খুব মানে কনভিনসিংলি বলা যাবে সেটা কিন্তু নয়। আমরা জানি না ইন দ্য সেন্স ইটস নট এক্সপেরিমেন্টালি ভেরিফাইড।
ওকে,
ও যে আলাদা হয় সেটা আমি কিন্তু বলছি না, আমি বলছি যে আমরা জানি না।
ঠিক আছে।
আচ্ছা, আর কেউ?
স্যার পিঁপড়ে দিয়ে যে এক্সাম্পলটা দিলেন ওটা আরেকবার একটু বলবেন স্যার?
কোনটা?
ওই স্ট্রিং থিওরির ওই ব্যাপারটা বোঝানোর সময় ওই পিঁপড়ে দিয়ে যেটা বললেন যে ওই পাতলা হলে একটা
হ্যাঁ,
ওটা
suppose
ব্যাপারটা
you,
একবার বলবেন?
okay. Suppose you take a cylinder. Okay, so cylinder means it has a length, right? And this, it is curled up surface. It has a curled up surface.
হ্যাঁ হ্যাঁ
Okay. Now suppose you stretch the cylinder. So if you stretch, due to volume preservation, it will be converted to a wire. তারে পরিণত হবে, তাই তো?
হ্যাঁ স্যার
একই না?
হ্যাঁ স্যার
বেশ, এবার তুমি স্ট্রেচ না করো, আমি যেটা বলতে পারি যে তুমি একটা তারকে কি আমি সিলিন্ডার হিসেবে অ্যাপ্রক্সিমেট করতে পারি কি পারি না?
হ্যাঁ
একটা তারও একটা সিলিন্ডার। The
হ্যাঁ
problem is that the radius is very small compared to known cylinders. Okay. এইবার ধরো একটা ant is moving on this wire. Okay, thin wire.
yes, sir.
We are looking at the problem from three space dimension.
Yes.
But if we are really living on such a thin wire, then this extra dimension means that due to this very small radius, the surface is curved up. Okay, this is an extra dimension, right?
Yes.
So that we will not be able to see.
Yes,
Similar things, according to string theory hypothesis, we have a string theory hypothesis earlier days that all those extra dimensions are curled up. Extra dimensions of the universe are curled up, very small, so that we cannot visualize in naked eye. Okay, or we cannot get the effect of those extra dimensions in physical properties, because gravitational law is there for very long. Coulomb force is there. They are in the sense in the study we have investigated theoretically as well experimentally for a long time. So if there are extra dimensions, that should have effect on this along the line I discussed today. Okay. Now, so that means it must have been very small, so that it is not affecting the observed physical phenomena. Okay. And as I said, even observations are two types. One, how do we observe in day-to-day life, and one we observe in the laboratory. And I mentioned about that experiment that beyond down 1 millimeter, we are not able to verify whether the Coulomb's law is valid or not. So that's experimental observation. Even experimental observation, we have a way we can think of. So there are extra dimensions, but those extra dimensions are very small, which even cannot be probed by present day technology. But that does not rule out that we cannot probe in a future using some sophisticated technology. But I must mention that those curled up extra dimension theory are now obsolete. Now they are talking about extra large dimensions. And as I explained, that the way you have studied, given a mass distribution, what is the gravitational potential or field at some distance due to this mass distribution? That depends on the shape of that mass distribution and the density. Similarly, for the charge distribution, say annular ring, sphere, cylinder, many things you have done from your higher secondary days. So extra large dimension, they consider particular shape of mass distribution for which there is no effect in our observed universe. Happy or no?
Yes, sir. Yes, sir.
বেশ, বলো আর কি আছে বলো। Anything else?
So that the wire, so that wire can act as one dimension and two dimensions simultaneously.
Urgen, I cannot hear you properly. Can you write it in chat box?
Yes, sir. So I want to say, sir, are you hearing me?
Yeah, I can hear you now. I can hear you. Continue.
So I'm trying to say that the wire which you said, so that wire can act as one dimension for someone and a second dimension for two dimension for the other person, something like that.
Yeah.
So just like
if you look at that from 3 dimension, then that looks
Yes,
like
sir.
a 2 dimension. But if you're really living on the wire, then I don't see
Yes,
that
sir.
curl up dimension. That's what your
Yes.
question?
Yes, sir. Yes, sir. So just like in a wire, if we are asked to walk, then we can only walk either front or back.
Yes.
And if an ant is said to walk on that wire, it can go front, backwards, left, right, or downwards, something like that.
No, you are thinking in terms of 3-dimensional view.
Yes,
Strictly 1-dimensional where you can move either forward or backward. There is no that you make a round just like gymnastics. You have a hanging rod and you are going around
yes,
that rod. That is not allowed. That is the
yes, sir.
3-dimensional view of the 1-dimensional object. But if you are really
Yes,
living in 1 dimension, you don't have that freedom, right?
yes, sir.
You have to move either forward or backward, no other way.
Yes, sir.
Okay. In fact, now I should mention here there is a very good book called Flatland by F.A. Abbott. Okay. Uh, he was a primary school teacher, but he had interest in mathematics, and that's long back before all this string theory and all these things. He wrote a book. It's a very interesting book. He and scientific, all science-based arguments. I forgot it's 1800 something. Suppose we are living in a hypothetical flat land, okay? Then what should be the construction of houses? How will be the atmosphere? And then how will be the climate? What will be the structure of human being? Okay, all these things are discussed very nicely, very long back, and these are very interesting things. Say, for example, if we are living in 2 dimensions, then really we will be in trouble, because you see that our uh, gastronomical system, that's basically a tube, right? But if it is strictly 2 dimension, then tube is not allowed. That's a cylindrical. Okay, only tape type of thing is allowed. So that means we should have a physical configuration where basically from mouth downwards it's not joint. Okay, so this kind of very interesting things, and if you can think in your spare time, this is very interesting that we are so lucky that universe is 3-dimensional. So it's basically related to our existence. Okay. If there is no other question, then I'll move with the convention. Any other question?
স্যার
বলো।
স্যার বলছি যে আমরা বিভিন্ন রকম মানে এটা স্যার একটু মানে বাইরে থেকে বলছি মানে আমি বলছি যে বিভিন্ন রকম আমরা যখন গেম গুলো তো দেখি গেমের গ্রাফিক্স গুলো যে মানে 2D হয় সেই রকম টাইপের আমরা চিন্তা করতে পারি।
Everything is 3-dimensional view of lower dimension. So difficult.
ওকে
Achha. So now for this course, I'll be using some convention that is, it's not my convention, standard convention all over the world, but there are some subtle differences from one convention to other, but grossly it's same. Say this is a relativistic system, so we'll be working in Minkowski space. Are you familiar with Minkowski space or no? I'm expecting a positive
Yes, sir.
answer.
Yes, sir.
When you studied special theory of relativity, you came across Minkowski space. Okay. Now, my convention will be that I'll be using Greek letters mu, nu, alpha, beta, gamma, delta, all these things for denoting 4 vectors, because Minkowski space-time means 3 space and 1 time variables, total 4 space variables, space-time variables. And if we write something with the index mu, that we should understand that I am denoting 4 vectors. On the other hand, Latin letters like I, J, K, L, M, N, O, P, that will be used only to denote spatial variables. For example, if I take a 4 vector, say a mu, so it has 4 components: time component, spatial components, When I am writing in terms of mu, that means mu can take values 0, 1, 2, 3. This is the 4 vector. But if you want to separate it out special values A1, A2, A3, then I can write it as AI. AI will imply that I takes values from 1 to 3, 1 to 3, because it only talks about spatial variable. You are not aware that there are two kinds of tensors, covariant tensor and contravariant tensor. And for covariant tensor, this index is a subscript. For a contravariant tensor, this is a superscript. Okay. Now, since you are talking about space-time, whenever you talk about a space-time, then we have to define a metric defined on the space-time, because this is essential to define the length. Say, whatever we are familiar with is the Euclidean space. And Euclidean space length is x square plus y square plus z square is length square. So that's the standard form, right? But the space can be different, and for the Euclidean space, the metric is 1, 1, 1, 1. Okay. Now here, Minkowski space-time, the metric is 1, minus 1, minus 1, minus 1. All of you will be following some kind of notes or books or web materials. You might face a situation where the metric is completely different from this. If it is different from this, what you will encounter is that this first one is minus and all three are plus. But that will not change the physical result or physical output. This is the convention. So that's what I am following, this convention, that either covariant metric tensor or contravariant metric tensor, this is a diagonal matrix with diagonal element given by this 1, minus 1, minus 1, minus 1. You may encounter a different convention where this is minus 1, plus 1, plus 1, plus 1. But the final result is independent of this convention. And as I said, that you define any space-time, you have to define a metric. That means you have to define a length, and the infinitesimal length element is bs square is equal to g mu nu dx mu dx mu. I will explain what is the meaning of this mu mu nu nu. I will explain immediately, unless you are already familiar with it. Now, the role of the metric is to make a connection between covariant and the contravariant tensor. This is the covariant tensor, this is the contravariant tensor. Suppose you are given a covariant tensor, how do you get contravariant tensor corresponding to that? Or the vice versa, you are given a contravariant tensor, how do you get the components corresponding to this contravariant tensor for the when it is covariant? So this is the relation. Okay, a mu is equal to g mu nu a nu. Again, I am using one more convention, very standard convention, that contracted indices nu nu, nu contravariant, nu covariant. So when a contravariant index and a covariant index are same, it's called contracted. Okay, or we say repeated, because nu nu, these are summed over. This is the convention. I will give you some example, it will be clear. One more thing you should remember, because that's a common mistake the students do throughout the course, is that the mismatch of indices. Suppose when you learn addition or subtraction in your school, then your teacher must have told, or some of your family member, that you cannot add 2 cows with 3 cats to get 5 cows or 5 cats. Okay, 2 cows plus 3 cats is 2 cows or 3 cats, but 2 cows plus 3 cows, total 5 cows. Similarly, if you have some equation, then free index, what is free index? This is contracted, right? Nu contracted. So there is a covariant index nu, there is a contravariant index nu. So these are contracted. Indices which are not contracted are called free indices. So in this equation, you see that this mu is not contracted, right? It's a covariant. There is no contravariant vector with the same index mu. So this is a free index. Right hand side again, G mu nu, nu is contracted with a nu, but mu is free. Okay. Whenever you write any equation involving tensorial notation, the free index on the left hand side and the free index on the right hand side should be identical. What do I mean by identical? Say if you write mu is equal to say 0 nu nu, that's wrong. And if you are attending some seminar, maybe some famous scientist or maybe some Nobel laureate is giving a lecture where it's written that mu is equal to 0 nu nu, unless it is a typographical error, you know for sure that that's wrong, and you can raise your hand, sir, excuse me, that's wrong. Okay. And this philosophy or this convention you should remember. But whenever I see the answer script, invariably, not all, but invariably, some of the students will not care about this free indices and then matching of indices. But note that this is not your attire or dress, that you want to be informal and want to wear funky dresses or something like that. This is science, and it has to be meaningful, and you have to follow the standard correct thing, that free indices of an equation on both sides should be identical, otherwise it's wrong. Okay. Now, to explain the idea, what do I mean by this contravariant, covariant, and repeated indices? Note that I'll be denoting the space-time coordinates as x mu, and inside the bracket I separate it out that time component x0 and the spatial components xi, I is equal to 1, 2, 3. Basically, this here I should have written actually x1, x2, x3. Collectively, I am denoting x1, x2, x3 as xi. Okay. Now, how do I this? If we use the index, then it's very convenient to work with. But how do I relate to our standard things, like we are habituated with talking like x, y, and z? So here is the relation that x0 is time t, x1 is equal to x, x2 is equal to y, x3 is equal to z. Okay, fine. Now, what is x0? Covariant component. What is x1? You see that x1 is minus x, x2 is equal to minus y, x3 is equal to minus z. Unfortunately, I don't have board, otherwise I could have shown him that suppose a is x. Okay, so the relation between this is that x mu is equal to g mu nu x mu. You have pen and paper with you or no? You have pen and paper with you?
Yes, sir.
Hello? Huh?
Yes, sir. আছে।
Okay.
Yes, sir.
তাহলে দেখ, হ্যাঁ, ওকে। সো তাহলে তুমি দেখো তো যে এই x1 সমান মাইনাস x হচ্ছে নাকি, মানে কোভেরিয়েন্ট কম্পোনেন্ট অফ x মিউ x1 ইজ ইকুয়াল টু মাইনাস x অর নট, হচ্ছে নাকি দেখো তো। এই দুদিক, এটাকে x ধরো, টেক a is equal to x, so you get the relation x0 is equal to g mu nu, sorry, if you take 0, a mu x mu is equal to g mu nu x nu, then left hand side you take x1. x1 is equal to mu is equal to 1, so g1 nu x nu, right? And then repeated indices summed over, so that means you can write g10 x0 plus g11 x1 plus g12 x2 plus g13 x3, right? But you know from the definition of this matrix that 10 is equal to k. g10 কত? What is g10?
0
Huh?
0
0. What is g12?
0
What is g13?
0
0.
Only g11 is non-zero.
yes
Yes, sir.
So if you use this repeated indices summed over, then you see that right hand side only one non-zero term, that is g11 x1. What is the value of g11?
0 minus 1
minus 1. So you get this result, x1 is equal to minus x, right? Yes or no?
Yes, sir.
Yes, sir.
Similarly, you do the same calculation for x2 and x3. On the other hand, if you do it for x0, only non-vanishing component on the right hand side will be g00 and g00 is equal to 1. So you get both quantavariant component x0 is equal to 2 and covariant component is x0 is equal to t. Both the cases you get t, but for other cases you get a minus sign. So it's very important. Okay. Clear? Or some of you are having still some confusions?
Clear,
Clear?
sir. Yes, sir.
আর কারো কিছু বলার আছে? ওকে
স্যার
বলো।
স্যার বলছি স্যার, ওই দুটো পয়েন্টের মধ্যে ডিস্টেন্স কোনো একটা ম্যানিফোল্ড কি মাইনাস হতে পারে?
কোনো
ওই কোনো ওই যখন আমরা ইয়ে পড়ছিলাম জিটিআর পড়ছিলাম তখন ওই দুটো পয়েন্টের মধ্যে ডিস্টেন্স ওই ম্যানিফোল্ডের উপরে ডিএস স্কোয়ার ইজ ইকুয়াল টু যে ওটা ওই দুটো পয়েন্টের ডিস্টেন্স কি কোনো ম্যানিফোল্ডের উপরে মাইনাস হতে পারে?
তুমি যখন জিটিআর করছো তখন টাইম ইনক্লুডেড।
আচ্ছা
ঠিক আছে। সো টাইম যখন ইনক্লুডেড তখন তোমার বিভিন্ন রকমের ডেফিনেশন আছে, স্পেস লাইক, টাইম লাইক, নাল লাইক। ওকে। সো দ্য ডিস্টেন্স বলতে যেটা, লেংথ বলতে যেটা বোঝায়, সে লেংথ ইজ নেভার নেগেটিভ। বাট তোমার বোধহয় আমি আছে এখানে কিছু পরে আছে যে ডিএস স্কোয়ার গ্রেটার দেন 0 লেস দেন 0 করে মানে স্পেস টাইমটাকে ক্লাসিফাই করা হয়। আচ্ছা আমার এখানে আমি কিছুক্ষণ পরে বলছি, দেখো তুমি কনভিন্স হও কিনা। Okay, this is the next one. So if you write the infinitesimal length element, then basically you see that what we had is ds square is g mu nu dx mu dx nu. So mu is contracted, nu is also contracted. Left hand side there is no free index, right hand side there is no free index. So what you have to do, you know that only G00, G11, G22 and G33 are non-vanishing. All other components of G mu are vanishing. So you just sum over. If you sum over, then we get dx0, dx0, dx1, dx1, dx2, এখানে কোথাও একটা ভুল করেছি, এখানে আমি এটা লিখতে ভুল করেছি, সরি। না না ঠিকই লিখেছি, কিন্তু তোমার এইখানে দুটোই ওপরে ছিল, আমি এখানে নিচে যেটা লিখেছি দেখো, সাপোজ দিস ইকুয়েশন আই ক্যান রাইট ইট অ্যাজ জি মিউ নিউ quantavariant dx mu, I can write it as covariant dx nu. Can I write এই ইকুয়েশনটা ব্যবহার করে?
Yes,
hello
sir. Yes,
Huh?
sir.
Yes, sir. Yes, sir.
Yes,
Okay,
sir. লেখা
so
যাবে।
basically next page I am using these two equations together. Now previous projection we found that x1 is equal to minus x1, x2 is equal to minus x2, x3 is equal to minus x3. So I am using here, and you get this infinitesimal length element in your familiar form. We are using natural unit, so there is no velocity of light. Basically you get c square dt square minus dx square plus dy square plus dz square. In natural unit, velocity of light is equal to 1, so it's not there. Now whatever you were asking, you see that depending on whether this is positive, negative or 0, this is the classification. Now ds square is difference of two positive quantity. Dt square is positive quantity, dx square plus dy square plus dz square, this is a positive quantity. Okay? If this is greater than this, then ds square greater than 0. If this is less than this, then ds square less than 0. There is a situation where this is equal to this, so ds square is equal to 0. Okay. Now when it is greater than 0, this is called time-like interval. When this is equal to 0, it's called null or light-like interval. And where ds square less than 0, this is called a space-like interval. Why this is called ds square is equal to 0 is called null, or null, you understand that null in the sense that right hand side is equal to 0. Why it is called light-like interval? Any idea?
লাইট এ ভেলোসিটিতে যাবে।
এক্স্যাক্টলি, লাইটের ভেলোসিটিতে যাচ্ছে, লাইটটা নিজের ভেলোসিটিতে যাচ্ছে, লাইটের ভেলোসিটিতে যাবে বলে নিজের ভেলোসিটিতে যাচ্ছে, সো দিস ইজ এ লাইট লাইক ইন্টারভাল। ওকে, নাও ইউ সি দ্যাট length, in the sense we define a length of an object, this is positive, always positive, dx square plus dy square plus dz square is always positive. Okay, but here when I am talking about greater than 0 or less than 0, perhaps you have difficulty in understanding this one. Somebody asked the question, I forgot to notice the name. You have the difficulty with this one or something else?
Yes sir, yes, হ্যাঁ স্যার এইগুলো স্যার ফিজিক্যাল ইন্টারপ্রিটেন্স কি, মানে এটা কি শুধু ক্লাসিফিকেশন না এর কোনো ফিজিক্যাল ইন্টারপ্রিটেশন আছে?
Of course physical interpretation আছে, তাহলে why should we classify?
Yes, yes.
Your question was how it can be negative, so I from the expression you can see there is a possibility that
Yes,
it can
sir.
be negative. When it is going to be negative, this is greater than this. Okay, so when we're talking about relativistic mechanics, then time is treated equally with spatial variables. Okay, so this distance is not merely the distance of the object, but space-time separation, right? I am writing in terms of dt, but you can write it as t2 minus t1. Similarly, dx you can write it as x2 minus x1, y2 minus y1, and dz as x3 minus sorry, dz. What did I say? dt as t2 minus t1, dx2 minus dx1, dy2 minus d1, dz2 minus dz1. So event is separated by time as well as space. If you're talking about only spatial separation, there is no time, then that length, that or distance, that is always positive because that negative length is meaningless. But since you're talking about space-time separation, it might happen that some event is occurring previous time, some event is occurring at a later time. Okay, and then there is the spatial separation. So both the combination is determining this length. Okay, so that's why you get these three cases, and you see that time-like interval, time is dominated. Time is dominated, but space-like separation is greater than the time-like time-like separation is greater than the space-like separation. That's why this first term is greater than the second term, and you get this. On the other hand, for this case, you find that the space-like separation is spatial separation is greater than the time interval. Okay, so you get this ds square less than 0. Clear?
Yes sir.
Okay, now we
টাইম
define
লাইক
four.
ইন্টারভাল কি পসিবল?
হ্যাঁ বলো,
টাইম লাইক ইন্টারভাল
টাইম লাইক
কি পসিবল?
কেন সমস্ত পসিবল নয় কেন?
না, ওটা যদি গ্রেটার দেন 0 হয়।
হ্যাঁ বলো।
না স্যার, ঠিক আছে ঠিক আছে।
t2 minus t1 সেইটা এতটা বড়, এই যে আমি যা বললাম x2 minus x1, y2 minus y1, z2 minus z1, সেই যে টোটাল স্পেশাল সেপারেশন যেটা তার যে লেন্থ হচ্ছে তার থেকে t2 minus t1 টা বড়, তখনই তুমি টাইম লাইক ইন্টারভ্যাল পাবে। আচ্ছা, maybe we will come at the end of this talk. Now 4 vector dot product, so this is the 4 vector, any 4 vector. This is the temporal component, this is spatial component. Similarly b mu, temporal component, spatial component, and যখনই মাথার উপরে whenever we give this vector sign, that means this is a spatial vector a1 a2 a3 b1 b2 b3. In typical vector analysis, we denote vector dot product as vector A dot vector B, and we give a arrow on top of a symbol to denote that this is a vector, right? That's the standard symbol, and in order to denote a dot product, we give a dot. The 4 vector dot product, we don't give a symbol of arrow on top of that 4 vector, but there is a dot. So if you find, say, from here A dot B, okay, this means the spatial component of A, 4 vector A, B with a vector sign means spatial component of a vector B, and the dot product is between the spatial components of A and B. But when there is no arrow sign on the symbol A and B, that means this is a 4 vector, and it's defined as A0 B0 plus AI BI. And again, if you're talking about Minkowski metric, then one can show that BI is this BI superindex superscript I is equal to minus B subscript I. So you pick up a minus sign from there, and then you get A0 B0 is equal to minus A dot B. Now, so we have defined 4 position vector. Now we define 4 momentum vector P mu. This is the 0th component, and either you can write it as a vector P or component from Pi. Whatever I have taught so far, so covariant P mu corresponding to this quantavariant P mu will be P0. This 0th component will not change, but due to nature of the Minkowski metric, this Pi will change for the covariant vector. It will be minus Pi. We denote energy E as 0th component for vector that you are familiar. I mean, you are familiar with from your special theory of relativity. So P0 and P0 is P. So that means this P mu with the identification of P0 as E, write as EPI. Similarly, covariant P mu with the identification of P0 as E for energy, as E minus Pi. If we write involving in 4 vectors P square, so this will denote the length of the 4 vector. P square is equal to P 4 vector dot P. This dot, P dot P, P square. P, suppose this B is equal to A. So A dot A, we can write A dot A or simply A square. And then right hand side has equal expression, same expression. So this is equal to P mu P mu. Now this is equal to M square. Can you see that P square is equal to P mu should be equal to M square, rest mass of the particle? Can you see?
Yes, sir.
কি করে বলো?
স্যার এটা তো m স্কয়ার c স্কয়ার হতো, সেটা তো 1 হবে।
একটু ডিটেইলে P mu সমান কি পাবে তুমি?
P mu স্যার m স্কয়ার c স্কয়ার হতো।
শুধু m স্কয়ার c স্কয়ার হবে না, না না সে তো হবেই, মানে কিন্তু মানে স্টেপটা চাইছি আমি, ইন বিটুইন স্টেপ।
ও আচ্ছা,
you are right that P mu is equal to m square, but in between step
স্যার e স্কয়ার মাইনাস p স্কয়ার হবে তো।
P0 square minus vector P square হবে, তাই তো?
ভেক্টর p, হ্যাঁ।
P0 square মানে হচ্ছে e square,
হ্যাঁ।
e square in natural unit is p square plus m square, right? 1 p square from P0 square cancels with this and you are left with m square. Okay, so this is a very important relation. This is a very important relation while appearing for NET, GATE, JEST, all kind of examinations you will be appearing within next few months. There are certain type of questions where you are allowed to calculate threshold energy for scattering and relativistic scattering and all these things. Okay, if you use this identity that P mu is equal to m square, because if it is a rest mass, you can go to any reference frame, this is not going to change, right? And using this identity, some of the calculations can be done very easily and in an elegant way. So look for any book on special theory of relativity or particle physics book by Griffiths. Okay, some calculations are given. we also need this relation very often, that P mu is equal to m square. So I'll be referring to this equation very often. I think you understand what I said, that why P mu is equal to m square. If not, then when I will give you the chance to ask the question, you will ask me. Now, P dot x, again, this is the 4-vector momentum, this is the 4-vector position. I am taking the 4-vector dot product. So P mu x mu, again you expand, P0 x0 plus Pi xi. P0 is E, x0 is T, so Et, and minus P dot R. So this is the special component of the 4-vector P, and this is the special component of the position vector R. So this relation we also need, but I think this is obvious. If you have followed whatever I have taught so far, this is obvious. Now I will be, আচ্ছা এইখানে বলো কারোর কোনো অসুবিধা আছে? কারোর কোনো অসুবিধা আছে যেটা বললাম সেখানে কোনো অসুবিধা আছে? Any problem? Any problem with whatever I have said so far regarding this 4-vector notation? No. কিছু একটা বলো, yes or no?
No, sir.
Hello. Okay. Okay. So now partial derivatives. This part is a bit tricky, and I find that the students have difficulty in following this. Now, to motivate you, you see that delta phi is a function of x0, x1, and x2, and x3. I can write it this as del phi del x mu delta x mu. This typically suppose phi is the function of x and y. You get del phi del x plus del phi del y dy dy. Right? Yes or no?
স্যার শুনতে পেলাম না।
Suppose you have a function phi. Here I should have put a comma, okay, or a full stop. So this part is, this delta phi on the right hand side is separate from this equation. This equation is only delta phi is equal to del phi del x mu stops. Okay. Now, are you familiar with this equation? Suppose you have a function phi which depends on variables x and y. Now, you want to calculate the infinitesimal change in the function delta phi. So what's the formula? Del phi del x dx plus del phi del y dy, right?
Yes, sir.
Yes, sir.
Okay. So the same thing I have written here in component notation, because del phi del x0 del x0 del x1 del x1 del x2 del x2 del x3 del x3. Okay, this is not included in the equation. Okay. Now if that is true, then now, if that is true, then you see that delta phi, this is a scalar quantity. That's what I mentioned here. Delta phi is a scalar quantity. On the right hand side, this delta x mu is a contravariant tensor or vector, contravariant vector or tensor of rank 1. So as I said, that left hand side and right hand side of equation should have the same nature. If the left hand side is a scalar, the right hand side must be a scalar. If the left hand side is a vector, the right hand side must be a vector. If the left hand side is a rank of some specified rank, say P, the right hand side should be also specified rank P. Now left hand side is a scalar, right hand side delta x mu is a contravariant tensor. So that means this delta phi delta x mu, delta phi delta x mu, this must be a covariant vector. right? Because this is a contravariant vector. There should be something which is contracted with this covariant vector to form a scalar, such that right hand side is a scalar just like the left hand side. Okay, so del phi del x mu must transform as a covariant vector. Now we define del mu as del of x mu. Note the difference. Again, this is a common point where the students uh, do the mistake till the end of this course. This mu is a subscript. This mu is a superscript of x, completely opposite. Okay, and component wise, the first component is del t, and this is a nabla or the gradient operator. Okay, why this is del mu and subscript, why superscript? I have explained it here, because this one has to transform like a covariant tensor. If this does not transform like a covariant tensor, then I cannot contract it with the contravariant tensor, and it will not be a scalar, but the left hand side is a scalar, so it will be wrong. So that's why I am denoting the whole thing del phi del x mu as del mu phi. I have not written phi here. Okay. Similarly, you can write the same equation. This mu, you can write it is subscript, and here you can write it as a subscript, and follow the same argument and define contravariant derivative operator, partial derivative operator, as del mu as del x mu. Note that again, this is a subscript, but this is a superscript. When you take the partial derivative with respect to covariant x mu, then the corresponding operator is denoted as a contravariant vector. Similarly, when you take the partial derivative with respect to a contravariant variable, the corresponding derivative operator is a covariant derivative operator. Okay, and here del x mu, similarly del t minus grad. This is the notation. Now, apart from this mathematics, you can think of in another form. Suppose you are taking a derivative of x mu. Okay, I'm sorry that I don't have anything to write. Maybe I'll switch over to my iPad after finishing this. If you have some calculation, I can do the calculation. Okay, so is it okay or not, or you have confusion?
Okay, sir.
Okay, if it is okay, and if your friends fail to understand, you just convince them. Okay, now we define an operator. It's called box operator. Box because it looks like a box. This is also known as D'Alembertian. Okay, and this is basically contraction of the covariant partial derivative and the contravariant partial derivative, and this has the expression del to del t square minus del square. When you have studied wave equation, then you have encountered this box operator or the D'Alembertian with this form. So I need not explain. Only I wanted to say that the box operator can be written very conveniently and elegantly using 4-vector notation as del mu. Okay. Now, so this is all about partial derivatives in 4-vector notation. Now we'll be studying electromagnetic field. So how to write electromagnetic, this vector potential, electric field, magnetic field in this 4-vector notation. So you learned something in Vishwajit's course or no? 4-vector notation of electromagnetic theory you have learned using 4-vector notation or not?
হ্যাঁ স্যার ক্লাসিক্যাল মেকানিক্সে হ্যাঁ স্যার ক্লাসিক্যাল মেকানিক্সে সিকোনটা বলেছিলেন
ইলেকট্রোডাইনামিক্সে করোনি? ক্লাসিক্যাল ইলেকট্রোডাইনামিক্সে
ক্লাসিক্যাল ইলেকট্রোডাইনামিক্সে ছিল হয়তো, মানে ঠিক মনে নেই, তবে সিকোনটা একটু পড়েছিলেন মনে আছে।
So you're familiar, so no problem. Okay, so again I have some mistake here. So this is not a new. Okay, so this is a typographical error here. This is a so this is correct. If some of you are taking note, this contravariant, right? Mu is not a subscript, mu is a superscript. Okay, this is a typographical error. So A superscript mu is equal to A0 vector A, and electrodynamics, you know this as scalar potential, and this you know as a vector potential. Now we define field strength as a rank 2 tensor F mu nu as del mu A nu minus del nu A mu. In the previous page, I have talked about the meaning of this operator and this operator, and this is the vector potential. So this is called field strength. Now F mu nu is an antisymmetric tensor with 6 independent components. How do you know this is an antisymmetric? How do you know this is an antisymmetric? Can anybody tell me? কেউ কি বলতে পারে এটা কি করে অ্যান্টিসিমেট্রিক হচ্ছে? হ্যালো,
হ্যাঁ স্যার, এটা
How do
মিউ
you
আর
check
নিউটা,
it?
স্যার মিউ নিউটা
হ্যাঁ,
যদি
বলো।
চেঞ্জ করা হয় তাহলে এফ মিউ নিউ ইকুয়াল টু
Interchange।
মাইনাস অফ এফ, হ্যাঁ ইন্টারচেঞ্জ করা হয়, তাহলে এফ মিউ নিউ ইকুয়াল টু মাইনাস অফ এফ নিউ মিউ হয়।
So it's antisymmetric, right? Yeah.
ইয়েস।
So আমাকে এবারে বলো যে একটা অ্যান্টিসিমেট্রিক টেন্সর অফ র্যাঙ্ক 2 কতগুলো ইন্ডিপেন্ডেন্ট কম্পোনেন্ট থাকে? একটা antisymmetric tensor of rank 2, how many independent components are there?
স্যার ঠিক জানার নেই স্যার।
আরে আর্গুমেন্ট দাও, জানার কি দরকার? একটা অ্যান্টিসিমেট্রিক ম্যাট্রিক্স, তার কতগুলো ইন্ডিপেন্ডেন্ট এলিমেন্ট থাকবে? ফরগেট অ্যাবাউট টেন্সর।
স্যার ডায়াগোনাল এলিমেন্ট গুলো আর ডায়াগোনালের এক পাশের এলিমেন্ট গুলো স্যার ওই ইন্ডিপেন্ডেন্ট হবে। আর
কে বলছো এটা?
স্যার অর্ণবী।
এলিমেন্ট তো থাকবে না।
ডায়াগোনাল এলিমেন্ট তো থাকবেই না। অ্যান্টিসিমেট্রিক ম্যাট্রিক্স যদি হয়, তার মানে এফ মিউ নিউ ইজ ইকুয়াল টু মাইনাস এফ নিউ মিউ, তাই তো? তাহলে তার মানে ধরো তুমি 0 0 কম্পোনেন্ট ধরছো, f00 ইজ ইকুয়াল টু মাইনাস f00। কখন এটা হতে পারে? একটা সংখ্যা তার নেগেটিভের সঙ্গে সমান কখন হয়? অর্ণব,
0 হলে।
0 হলে। তাহলে f মিউ নিউ ইজ ইকুয়াল টু মাইনাস f নিউ নিউ।
তাহলে 6টা,
হ্যাঁ তাহলে 6টা হবে।
6টা কি করে হলো তারপরে?
না না না, ডায়াগোনাল গুলো বাদ যাচ্ছে আর বাকিগুলো থাকছে।
বেশ, এমনি একটা টেন্সর অফ র্যাঙ্ক 2 এর কতগুলো ডায়াগোনাল বাদ দিলে কতগুলো পড়ে থাকছে?
টেন্সর র্যাঙ্ক 2 এর
মোট কতগুলো কম্পোনেন্ট আছে?
একটা থাকবে
স্যার 2 টু দি পাওয়ার n যদি,
হ্যাঁ
2 টু দি পাওয়ার n করতে,
হ্যাঁ
স্যার 2
টু দি পাওয়ার n করতে গেলে
না স্যার 4 যদি
লাটটা
n
যদি
প্লাস n হয়,
একটা 4x4 ম্যাট্রিক্সের কতগুলো ইয়ে থাকে?
4x4 16টা এলিমেন্ট থাকে।
স্যার
দিস ইজ লাইক এ ম্যাট্রিক্স। বেসিক্যালি তোমার স্পেস ডাইমেনশন যত হবে টু দি পাওয়ার র্যাঙ্ক, নাকি 2 টু দি পাওয়ার 4 র্যাঙ্ক টু দি পাওয়ার 4, কোনটা ঠিক? এক্ষেত্রে তো দুটোই এক হচ্ছে, 4 স্কয়ার আর 2 টু দি পাওয়ার 4।
স্যার
4 স্কয়ার
4 square is the correct answer because 4 square is the correct answer. Okay, so the dimension to the power rank. আচ্ছা, তো 16টা থেকে you subtract the diagonal element. Diagonal element, how many diagonal elements? 4, right? So 16 minus 4, how many?
12.
12.
Huh? 12. Now we have the condition that f mu nu is equal to minus f mu nu. That means f01 and f10 they are not independent. f20 and f02 they are not independent. Similarly for all other off-diagonal components. So that means 12 by 2 you have 6 independent components, right? Clear na clear নয়?
Clear, sir.
তুমি একা কথা বলছো আর কেউ বলছে না?
Sir, can you
সন্তু,
explain again?
Clear, sir, clear.
শালিনী,
Yes.
Not clear, sir. Can you explain
clear.
again?
So you understand that it should have 16 components. You agree with that?
Yes, sir.
Now if the diagonal elements are 0, so there are 4 diagonal elements, so we subtract 4 from 16. So 16 minus 4 is equal to 12. You agree with that?
Yes.
Now antisymmetric means f mu nu is equal to minus f mu nu. Agreed?
Okay.
So that means, say suppose you take the component 01. So you see that component 01 and component 10, they are related to each other. f01 is equal to minus f10, right?
So here I didn't understand.
So you have the definition for f mu nu. You have the definition for antisymmetric tensor as f mu nu is equal to minus f nu mu. Mu nu nu mu. So if you take mu is equal to 0, nu is equal to 1. So left hand side, what do you get?
F mu nu equals to minus F
Nu mu.
Hmm.
Interchanged.
mu mu.
Mu and nu are interchanged. Now take a
Okay.
particular value of mu and nu.
0 and 1.
Yes. So what do you get on the left hand side?
1 and 0.
Left hand side, f01, right?
Yes.
Right hand side,
1 and 0.
minus f1.
Different. Yes.
So are they independent?
No.
So out of these two, you get only one independent quantity, right? So you do it for all other elements and you'll find that there are not 12 but 12 by 2. There is a pair f01 f10, f02 f20, f03 f30, f12 f21, f13 f31, f23 f32. This is a pair. They are not independent. So 12 by 2 you get 6 independent quantity. Clear?
Yes, sir.
Okay. So we have to identify these 6 independent components, and that's what I have done here. That you have electric fields, 3 components, and the magnetic field, 3 components. Okay. Now you see that EI, suppose you take I is equal to 1, that x direction of electric field, minus f01. Minus f01, using the definition of field strength, del 0 A1 minus del 1 L0. What is the definition of electric field in your standard notation? E is equal to minus grad phi minus del A del T, right? So this is reproduced. Similarly, this is defined as minus half epsilon ijk fjk. That means this is magnetic field. Now here we have defined this epsilon ijk is Levi-Civita tensor. Epsilon 1, 2, 3 is equal to 1. This is the definition. Now if you make even number of permutations of indices plus 1, you get, if it is odd number of permutation, you get a -1. Say for example, if it is epsilon 1, 2, 3 is equal to 1, then what is the value of epsilon 2, 1, 3? 1, 2, 3 and 2, 1, 3, that means only one permutation. So that is odd number of permutation. So that means epsilon 2, 1, 3 will be equal to -1. On the other hand, epsilon 3, 1, 2, you have to move left once, you have to move left towards left twice. So 3, 1, 2 means you have permuted twice. So it's an even number of permutation, you get a plus sign. Okay, so this is the definition of Levi-Civita tensor. Now we generalize this Levi-Civita tensor in Minkowski space-time as mu nu lambda rho. Okay, and there the defining relation is that epsilon 0, 1, 2, 3 is equal to 1, and then again even number of permutation we get a plus sign, odd number of permutation we get a minus sign. But there is a difference. For Levi-Civita tensor, it is defined in Euclidean space. Contravariant epsilon 1 to 3 and corresponding covariant epsilon 1 to 3, there is no difference. You get only one. Here, if you use the metric to raise or lower these indices, you will find that 0, 1, 2, 3 is equal to -1. Okay, this Levi-Civita tensor will be also using. আচ্ছা, almost এটা হচ্ছে কি তোমার it's 4:27. I don't want to go beyond, but I give you one opportunity because I didn't do any board work. I don't have. I'm still learning. So if some of you want to ask something and want me to explain using board work, then I will give 5 minutes break and I will switch on my this iPad where I can write using my pencil, and the same Google Meet I will try to connect using my another email address. So do you have any question? Then I will do that. Otherwise I just simply stop here, and next class I will start teaching you Lorentz transformation and all this. But even if you are not interested, after 2 hours of one-sided listening, বলো অর্ঘ বলো।
লেবি-সিবিটা টেন্সরের ব্যাপারটা একবার বলো। লেবি-সিবিটা টেন্সরের ওই সেটি প্রপার্টি।
আচ্ছা, তোমাদের কেউ নিশ্চয়ই খুব স্মার্ট ওয়েতে এইখানে কোনো হোয়াইট বোর্ডের একটা ব্যবস্থা আছে না, জানো? এই গুগল মিটে হোয়াইট বোর্ড কোথায় আছে জানো কেউ তোমাদের?
নো স্যার, গুগল মিটে হোয়াইট বোর্ড ডিরেক্ট মনে হয় ইউজ করা যায় না, এরকম
আচ্ছা
জানেন না?
দেখছি না। দেখছি, আমি একটা লিংক পাঠাচ্ছি, দেখা যাক। দেখো কিছু পেয়েছো, তোমরা পেয়েছো কিছু লিংক?
Yes sir.
হ্যাঁ স্যার, চ্যাট বক্সে লিংক দেখাচ্ছে একটা।
আচ্ছা,
লিংক
তোমরা কি হোয়াইট বোর্ড দেখতে পাচ্ছো? দেখতে পেয়েছো? হ্যালো, আমি যা লিখছি সেটা দেখতে পাচ্ছো? হ্যাঁ
না স্যার, হচ্ছে এখনো
স্যার আমার ফোনে হবে না বলছে ইওর ডিভাইস ইজ নট ক্যাপেবল উইথ দিস ভার্সন।
বেশ, একটু কি তোমাদের মানে আর কোনো কাজ আছে? একটু অপেক্ষা করো, তাহলে আরেকটা জিনিস আমি তোমাকে জাস্ট আমার মানে আইপ্যাড থেকে শেয়ার করতে পারবো। একটু কি অপেক্ষা করবে না পরের দিন?
ওকে স্যার, ওকে
না সবাইকে
নিয়ে
হ্যাঁ
আসুন।
হ্যাঁ স্যার, অপেক্ষা করছি।
বেশ, তাহলে আমি এটাকে ক্লোজ করিয়ে দিলাম। Everyone? Hello? Hello?
হ্যালো স্যার, প্রচুর
শুনতে
নয়েজ
পাচ্ছ?
আসছে।
Hello?
হ্যাঁ স্যার, হ্যাঁ স্যার, নয়েজ আসছে খুব মাঝে মাঝে। এবার ঠিক আছে।
হ্যালো, শুনতে পাচ্ছ? শুনতে পাচ্ছ?
হ্যাঁ স্যার, শোনা যাচ্ছে।
হ্যালো?
হ্যাঁ স্যার, শোনা যাচ্ছে।
নয়েজ?
স্যার কথাটা ইকো হচ্ছে।
হ্যাঁ, সেটা তো বুঝলাম, কেন হচ্ছে সেটা তো আমি আবার বুঝতে পারছি না। Yeah. Hello? Yeah, শেষ।
হ্যাঁ স্যার। স্যার একসাথে কি দুটো জিনিস আপনার মানে ওপেন করা আছে, যার জন্য হয়তো দুটো থেকে সাউন্ড
কিন্তু
আসছে?
অনেক ইকো।
হ্যালো?
হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার।
বেশ, ঠিক আছে। আগে দে এটা। না বলো, প্রশ্ন আমি লিখে দেখাচ্ছি। হ্যালো, হ্যালো।
হ্যাঁ স্যার, শোনা যাচ্ছে।
হ্যাঁ, তা বলো, প্রশ্নটা বলো, আমি লিখবো তো, লিখে বোঝাবো কি বলছিলে
স্যার
বলো।
অর্ণব কি জিজ্ঞাসা করছিল? অর্ণব কোথায় গেল?
হ্যাঁ বলো অর্ণব, বলো অর্ণব আছে না নেই?
স্যার আছি। আমি না স্যার,
অর্ণব,
অর্ঘ্য জিজ্ঞাসা করছিল। হ্যাঁ স্যার আছি। স্যার
হ্যাঁ বলো
অর্ঘ্য
বলো।
জিজ্ঞাসা করছিল।
হ্যাঁ
অর্ঘ্য
প্রশ্ন,
জিজ্ঞাসা করছিল স্যার, ওই
হ্যাঁ বলো
ওই
প্রশ্নটা।
ওই ওই লেভিসিভিটার ওখানটা জিজ্ঞাসা করছিল অর্ঘ্য স্যার।
আচ্ছা আচ্ছা আচ্ছা, দেখো স্ক্রিনে দেখো। ঠিক আছে, এইটা হচ্ছে ডেফিনিশন। ওকে।
আচ্ছা,
হ্যালো।
হ্যাঁ
বেশ,
স্যার।
এইবারে তোমার ইভেন নাম্বার অফ পারমুটেশন বলতে কি বোঝাচ্ছি? ইভেন নাম্বার অফ পারমুটেশন বলতে বোঝাচ্ছি, ধরো তুমি আগে অডটা বলি, এপসাইলন 2 1 3 সমান কত হবে এটা যদি তুমি বের করতে চাও। ওকে, তাহলে দেখো এখানে 1 2 3 আছে, আমি দুইটাকে একে নিয়েছি, একটাকে দুয়ে নিয়ে গিয়েছি, সেটা কতগুলো পারমুটেশন এটা?
একটা।
হ্যালো, একটাই পারমুটেশন। তার মানে এটা অড নাম্বার অফ পারমুটেশন, তাহলে এটা কি হবে? ডান দিকে +1 হবে না মাইনাস হবে?
মাইনাস।
হ্যালো, -1।
স্যার এটা ক্লকওয়াইজ বা অ্যান্টি ক্লকওয়াইজ আমি যে কোনো ভাবে ধরতে পারি?
হ্যাঁ, যে কোনো ভাবে ধরতে পারো। যে যদি পারমুটেশনের দুভাবে বলা যেতে পারে, যে তুমি যেটা বলছো যে ক্লকওয়াইজ অ্যান্টি ক্লকওয়াইজ, এবারে যদি সাইক্লিক পারমুটেশন করো, তাহলে সাইক্লিক পারমুটেশন করে এটার সাইন চেঞ্জ হবে না। ঠিক আছে, তুমি যে ডেফিনেশন বলছো সেটাও একটা ডেফিনেশন। কি রকম? যে সাইক্লিক পারমুটেশন মানে হচ্ছে যে এপসাইলন 1 2 3। এবার আমি করলাম কি, সাইক্লিক পারমুটেশন 1 2 3। ঠিক আছে, তার মানে কি করলাম, এইভাবে যদি ঘুরতে থাকি তাহলে 3-এর জায়গায় 2 বসালাম, আবার 1-এর জায়গায় 3 বসালাম, 2-এর জায়গায় 1 বসালাম, তাহলে কি হবে বলো? একটা পারমুটেশন যদি করি তাহলে কি হবে বলো? হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার, শোনা যাচ্ছে। হ্যালো?
শুনতে পাচ্ছ না পাচ্ছ না?
হ্যাঁ স্যার, শোনা যাচ্ছে। হ্যাঁ স্যার, শোনা যাচ্ছে।
So yes, sir.
হ্যালো,
Yes, sir. We can hear you.
হ্যালো উর্গেন, ক্যান ইউ হিয়ার মি?
Yes, sir. Yes, sir.
হ্যালো,
Yes, sir. We
হ্যাঁ
can hear
শোনা
you.
যাচ্ছে।
হ্যাঁ
Yes, sir.
স্যার শোনা যাচ্ছে।
Yes, sir. We can hear you.
Hello, can you hear me, Urgen?
Yes, sir, we can hear you.
Hello?
Yes, sir, we can hear you.
Hello?
হ্যালো স্যার, আমরা শুনতে পাচ্ছি।
No, I cannot hear you.
We can hear you, sir.
Okay. Now, continue. Now I can hear you.
স্যার আপনার একসাথে দুটো মাইক অন আছে, ওই জন্য কথাগুলো ইকো হচ্ছে। একটা অফ করে দিই আর
হ্যাঁ, না বলো, অফ করা আছে, বলো।
হ্যাঁ স্যার, এবার ঠিক আছে।
বলো, প্রশ্ন বলো, আমি লিখেছি, বলো। হ্যালো? শুনতে পাচ্ছো?
হ্যাঁ স্যার, শোনা যাচ্ছে। স্যার শুনতে পাচ্ছি।
হ্যালো? এই প্রশ্নটা করো, আমি তো
হ্যাঁ স্যার,
বললাম।
শোনা যাচ্ছে।
হ্যাঁ, এবার বলো, প্রশ্নটা করো, আমি তো তোমাকে শোনা যাচ্ছে, কিন্তু আমি
হ্যাঁ স্যার,
তোমার যে
অর্ক
সাইক্লিক
প্রশ্ন
পারমুটেশন
করছিল।
বলছিলে, সেই সাইক্লিক পারমুটেশন।
হ্যাঁ
অর্ঘ কই, চুপ করে কেন? অর্ঘ বলো কথা।
আমার স্যার শেষের যে পয়েন্টটা বলেছিলেন ওখানে সেই পয়েন্টটা বুঝতে মানে সমস্যা হচ্ছিল।
কোনটা বলো?
ওই যে পিডিএফটাই ছিল, ওই পিডিএফ এ যে শেষের পয়েন্টটা ছিল।
আচ্ছা, বেশ, ঠিক আছে। এইটা কি দেখো, আমি বলছিলাম।
না না, এটা ঠিক আছে। হ্যাঁ স্যার, এইটা।
এইটা তো
হ্যাঁ
এইটা তো
আচ্ছা।
এইটা বুঝতে অসুবিধা হচ্ছিল?
হ্যাঁ হ্যাঁ
বেশ, এবারে তুমি দেখো, এখানে তুমি কোভেরিয়েন্ট এন্ড কন্ট্রাভেরিয়েন্ট, এখানে একটু কমপ্লিকেটেড। এখন 4টে ইন্ডেক্স আছে, সেইটা তোমাকে লিখতে হবে এরকম ভাবে: এপসাইলন মিউ নিউ ল্যামডা রো সমান জি মিউ আলফা ইন্টু জি নিউ বিটা ইন্টু জি ল্যামডা গামা ইন্টু জি রো ডেল্টা।
হ্যালো স্যার, কিছু শোনা যাচ্ছে না। কেউ শুনতে পাচ্ছিস?
না, কিছু শোনা যাচ্ছে
শোনা
না।
যাচ্ছে না। Where is sir?
হয়তো কোনো নেট প্রবলেম হচ্ছে তাই স্যার লেফট করেছে, মেবি।
Completely silent হয়ে গেছে।
হ্যালো হ্যালো,
হ্যাঁ স্যার শোনা যাচ্ছে।
Yes sir, we can hear you.
এই বোর্ডটা কি চলে গেছে?
হ্যাঁ স্যার।
বেশ ঠিক আছে, আর কোনো প্রশ্ন আছে? মানে আমি যেটা লিখলাম সেটা দেখতে পেলে না পেলে না?
হ্যাঁ স্যার
পেলাম।
দেখা গেছিল।
হ্যাঁ
হ্যাঁ স্যার
পেলাম।
দেখা গেছে।
বেশ ঠিক আছে, আজকে অনেকক্ষণ হয়ে গেল, আজকে তোমরা ইউ মাস্ট বি টায়ার্ড। পরের দিন ইয়ে করবো, মানে তোমার লোরেন্স ট্রান্সফরমেশন পড়াবো। আর যদি কোনো প্রশ্ন থাকে সেটা বলো। শুধু একজন বা দুজন তোমাদের ভলেন্টিয়ার থাকতে পারবে। আমি মানে একটু আইপ্যাডের সঙ্গে কিভাবে করতে হয় সেটা দেখতে পারলে হয়তো এই টেকনিক্যাল প্রবলেমগুলোকে অ্যাভয়েড করতে পারবো। বাকিটা চলে যেতে পারো, যে কোনো একজন বা দুজন ভলেন্টিয়ার যদি থাকো তাহলে আমি তার সঙ্গে বসে এটা
সুমন শুনতে পাচ্ছিস?
কেউ
সুমন
শুনতে পারে না।
দেখ স্যার, হ্যাঁ তুই থাক। স্যার তুই থাক, আমরা তাহলে লেফট করছি স্যার।
হ্যাঁ কি
কি
বলছো?
জানতে?
হ্যাঁ
স্যার আমরা তাহলে লেফট করছি, সুমন ও মোটামুটি জানে, ও বলে দিতে পারবে।
আচ্ছা বেশ ঠিক আছে, ঠিক আছে, পরের ক্লাসে দেখা হবে। ওকে,
ঠিক আছে স্যার।
সবার জন্য ছুটি, সুমনের সঙ্গে কথা বলি।
আচ্ছা।
হ্যাঁ দাঁড়াও সুমন, এই আমি এইটা বন্ধ করি, বন্ধ করে আমি আইপ্যাড থেকে করার চেষ্টা করি। এটা পুরোপুরি দুটো করতে গিয়ে অনেক রকম সমস্যা। এটা আমি পুরো এই মিটিংটা আমি ক্যান্সেল করছি, করে তোমাকে একটা নতুন লিঙ্ক পাঠাচ্ছি। ঠিক আছে, এটা আমি বন্ধ করে দিচ্ছি।